Alright, so in this video, we're kind of starting about metallic solids, but first we're going to talk about some alloys. They're kind of a special type of metallic solids. An alloy is a material that contains more than one material and has the same characteristic properties of a metal, meaning it's like a homogeneous mixture, if you will, of metals. So like brass, like stainless steel, like almost every type of wedding ring you see. There are multiple metals in one substance. Alloys, as with almost everything, can be divided into two categories. Substitutional alloys and, it's not transitional, it's interstitial alloys. So, not really sure where transitional came from. Substitutional alloys occur when atoms of the solute in a solid solution occupy positions normally occupied by a solvent atom. Let me give you an example. Okay, as you can tell, not quite the greatest artist, but it's good enough. Basically, substitutional alloys, when we substitute in a different element to a compound. So if the red is basically the solvent and we occasionally have blue, that's a substitutional alloy. It really doesn't look a lot different, except you just got, like, shape-wise, doesn't change a whole lot. These occur when the two metallic compounds have very similar radii, meaning they're basically about the same size, because otherwise you would change really the shape of the molecule. Thus, the compound typically remains flexible, remains ductile if it was to begin with, and has kind of a similar density. A whole lot of it doesn't really change. This is really common. Well, that's on the next slide. Common substitutional alloy is brass, which is when copper and zinc form an alloy. They're very similar in terms of size, but you've got copper and zinc mixed together, and there you go, you got brass. Other common examples are those in wedding rings. When you've got gold, silver, and sometimes even copper, that's how we get rose gold or white gold. It's not just a different form of gold. Gold is gold. But you can make substitutional alloys to make it look like it's a different color of gold. And technically it's still gold. It just may also be copper or silver. Interstitial alloys are when the solute atoms occupy the spaces between the solvent atoms, as if you're actually filling in the gaps. Let me give an example. So here we can see the original, and then we filled in the gaps with some other element. That's an interstitial alloy. In case you'd like to know, those gaps are called interstices, which is why it's interstitial alloy. Just kind of random trivia. That type of alloy really can only occur when the solute is much smaller than the solvent, because it's got to actually fill in the gaps between the solvent atoms. But as we fill in those spaces, that's less space for the atoms to move, so you get a much stronger, harder, and much less ductile compound. Very common example is steel, which is an alloy of iron with carbon or other elements in it, and also stainless steel, which is iron with some carbon, some zinc, a little bit of nickel, and a couple other compounds. They're much harder, much stronger, if you will. So, thanks for watching.